I hope you watched my first lecture related to electrolysis. So here we come to the topic dissociation and ionization. Students, already I have explained in chemical changes and reaction chapter class 9 that what's the difference between chemical dissociation and ionization. Here once again I am saying that dissociation means separation of ion. Suppose sodium chloride, okay, presence of water, they will form Na plus and Cl minus. Okay, so main thing you just remember, electrovalent compound, those are electrovalent compound and electrovalent or ionic compound, they will dissociate into their respective ions because they are okay. uh, but in covalent compound, students, covalent compound, because electrovalent, they will form like this way also. First sodium will form Na plus, chlorine form Cl minus, then come closer form NaCl, so they will do the reverse thing. But in covalent compound, student, mutual sharing of electron happens. Okay, so mutual sharing of electron happens means that bond is weak, but they will not convert it into ion properly, means they will not dissociate. Okay, so they will ionize. That if for HCl, this bond, water will come, water will pull H plus, okay, and Cl minus also as well from this side, and they ion will produce. Oh, okay, ionization, that is called ionization. Okay, so students, I hope you understand. In this case, ions are already present, just they need to separate, we need to separate the ions. But in this case, uh, ion will not form, water will make them to form ion, so that is ionization, this is dissociation. Okay, now come to the direct the process of electrolysis. Students, here you can see the electrolysis of sodium chloride, molten sodium chloride, and second electrolysis of lead bromide. That too, the electrolysis present in your book, that I will explain over here. First is the molten sodium chloride. Students, in the process of electrolysis, there is a tub like this, okay, or there is a container, you can say. Okay, heat is generating, you have to give in the heat, and there the electrolysis, electrolyte you need to take, that is molten NaCl. Okay, so take a molten NaCl here. Molten NaCl means Na plus and Cl minus ion is there. We need to place two electrode. Okay, so that is this is called as a complete cell. Okay, complete cell. Okay, there is a container, sodium chloride solution, means molten sodium chloride, and there is two electrode, left side, you can say both side, one is cathode, negative, that is called cathode, and another side is positive, you can say anode. Okay, negative cathode reduction, positive anode oxidation. This is the short form, you can remember, NCRPAO. Okay, NCR means negative cathode reduction, PAO means positive anode oxidation. Okay, so positive anode oxidation means oxidation takes place in anode, and in cathode reduction takes place. This is the short form, you can remember. Okay, so how the reduction means? Reduction means gaining of electron. So as the reduction in cathode takes place, so when the electricity, when you are giving the heat, then the electrolyte will dissociate into sodium plus and Na plus and Cl minus ion, so that Na plus will attract towards the cathode. Okay, that cation cathode, anion anode, you just remember this thing. So Na plus will come and accept electron from the cathode, because cathode negatively charged. Okay, cathode negatively charged. Okay, that these both are called electrode. What is a electrode, that I will explain, no problem. Just remember how the reduction and oxidation happens. So cation will move to the cathode, and they will accept electron because it is negatively charged and form Na sodium metal, okay, and deposit on it because it's become neutral after accepting the electron. It will, so cation move to the cathode, accept electron and deposit on it, okay, deposit on it. So in cathode this reaction happens, and in anode anion will move Cl minus, so Cl minus will release one electron, means this reaction happens. Cl minus chlorine will release one electron and form release one electron and form simple chlorine, okay. And you know this is chlorine will not exist like this way, so 2 chloride will form Cl2 plus 1 electron, okay, plus 2 electron, okay, multiply by 2. So as in anion sorry, in anode we multiply with 2, so in cathode side also multiply with 2, 2 Na plus 2 electron 2 sodium, okay. So in the reduction side, one molecule of chlorine gas will produce by depositing of 2 molecule of sodium, okay. So sodium will deposit on the cathode, and in anode you can see the chlorine gas, okay. So this is the complete electrolysis of molten sodium chloride, okay. Now student, come to the electrodes. What is the electrodes? Electrodes are the you can say the reaction act as a discharge tube, you can say. No, not discharge tube, means rod, okay, rod. Electrodes are a rod, okay. Here I already mentioned electrodes are generally called rod, which used for discharge purpose, discharge of ions, okay. Without discharging, how the conduction happens? By this way to electrolyte, means you are giving heat, ion will produce, cation move to the cathode, anion move to the anode, then cation will accept electron from the cathode, this reaction happens, anion release electron in anode, this reaction happened. Then what happened? That electron will flow of cation and anion takes place inside the solution. That means a conduction happens, and that is the discharge of the ions happens in the electrode. So electrodes are the rods, okay, where the discharge happens, okay. So student, that is the electrolysis of molten NaCl. Next video I will explain electrolysis of molten lead bromide. If you want understand, other are very easy, okay.